In this particular session, we're going to discuss about a Hello World C application. Before we start, we need to understand why we need to learn C. Basically, C is the most fundamental language. Most of the operating system kernels, most of the applications we use written in C. So, C is very important from that standpoint. Also, C++, which is the object-oriented version of C, pretty much, is a superset of C, which means to learn C++, you need to learn C first. So then why people talk about languages like C#, Java? In most cases, there are more job openings for C# and Java. The reason is, while most of the boilerplate code is written in C and C++, most of the custom logics are written in C# and Java. So if you have a custom application which is used for only in a particular company, which doesn't need much of a performance and things like that, you may go for Java. A good example is a website or a web application for a company. You may go for Java or C# instead of C or C++. There are so many libraries built around C# and Java, for example, which makes the development of those languages much easier compared to C and C++. Then obviously the question is why we learn C. Why can't I learn Java or C#? Because I don't know anything. So the reason is those languages are not fundamental languages. Those languages abstract a lot of things from you, and to learn fundamentals you have to start with either C or assembly. So that is exactly what we're going to do here. Start from the basics. Being said that, we are all set to start a Hello World C program. So we're going to go ahead and start a Visual Studio and write a C application. I have started an instance of Visual Studio, which is the integrated development environment from Microsoft. When I start Visual Studio, this is how it looks. So go to File, click New, Project, Win32 console application, enter a project name here. I have given the name test Hello World. Click OK. Click Next. Finish. So now we have got a main and a very simple C application. This particular application doesn't do anything. So to make it do something, I'm going to include a header file, #include stdio.h, and I'm going to call a function called printf. So this is the C application we have just written. Let's not worry about this particular line, so we will see it later, but make sure that you don't delete this particular line when you do the programming with Visual Studio. Also, don't worry about this underscore main. Even if you change it to main, it'll work. We are not going to care that at the moment. Also, don't worry about this command line arguments. We are not going to discuss those things now. So to make things simple, I'm gonna delete those. So maybe I'll delete this as well. I'm gonna change it to void, so I don't need to return anything, or I don't need this statement at all. So now the application became more simple. If I change some settings, I can remove this as well, but I'm not going into it at the moment, so let it be here at the moment. So we'll see this detailing later. So basically from here to here is our application. So let's see how it works. So I'm gonna save this. So I'm gonna right click on the project in the Solution Explorer. So here is a Solution Explorer. So we can see all the files related to this particular project. So here I'm gonna right click and build. Oh, build failed. Oh, I missed one T here. Yep, that's it. So now we have to execute it. So for execution, I have pressed the play button on the top. Basically, it got executed. So we couldn't see it. To see it, we have to stop that application execution somewhere. So for that, what I'm gonna do is I'm gonna put a breakpoint, and I'm gonna break there and press F10. So now I can see it here. Or another option I have is to see it. So include another header file, #include conio.h get ch. So if you do this, you can see it without putting a breakpoint. I'm gonna remove this breakpoint. So here it is. Basically it's waiting on this particular call. So if I press enter, it will go. So this is our Hello World C application. So now we're gonna see a couple of more things. So suppose if you want to print a number, %d, comma 10. So this %d is going to get replaced with this particular 10. Let's see that. Here it is. So I can put that into a variable. So int a equal to 10. So we're gonna see this in detail later, don't worry about it. So int a. So we're gonna get the same result pretty much. I can put a string there. Say for example, if I want to give a string, another string, test, this is not needed. stop debugging. I'll get the test printed. So if you have noticed, I have used percentages. So percentages is for string and percentage D is for decimals. So how do I know all these things? That is where the documentation comes. So we will go into the documentation of this particular function later. Before that, we will see another function called scanf. So printf is to give output to user. So scanf is just do the opposite. Scanf will take input from user. So let's see that. So scanf. So before that, I need a variable to hold I need a variable. So int a is a variable. We're gonna see this later. So we need a variable to hold the input of the user. So this is a syntax of scanf percentage %d. It's very similar. So percentage %d ampersand a. So don't worry about this ampersand at the moment. So you may have to wait a little bit to understand this completely. So don't forget this ampersand. So ampersand is needed. So don't forget it. So percentage %d ampersand a. So what we are going to tell. So let's make sure that this will get compiled. Yeah, compiler is happy. So by the way, the build is almost equivalent to compilation for the time being, but there is something else called compilation. So control F7. So if you want to really compile the file, we can do that here. So coming back, so scanf, what we are going to tell the compiler or the application is whatever input user is giving, put it into a, the variable a, which I have defined before here. So let's do this. So percentage %d a. So I'm gonna do the same statement here. Control C, Control C, Control V here. So I have data print up here. Hopefully it will print the statement A, which is 0. After that, I'm taking the input from user and putting it into A and printing it again. Okay, so that's it. So let's start the application. Okay, first one is hello world 0. That's what we were expecting, right? So now I'm gonna enter the number, say 98. I'm gonna press 98 here and press enter. I press enter key. Look at that. So now this line got executed and the value of A is 98, which is the 98 I have given here. Let's understand a little bit more what's happening. So again, as we discussed before, I'm going to put a breakpoint here. So in the debug menu of Visual Studio, there is a window which will come up when we start debugging called watch. That is the window we're gonna use. to see the actual value of A. So let's see. So start debugging again, same application, start debugging again. So in this case, what I'm gonna do is debug watch window. So now as the debugging has started, you can see a lot more things has come up. So I'm gonna select watch 1. So what I'm gonna do, I'm gonna drag and drop this A into the watch window. Look at that, the A is a local variable and it contains junk at the moment. So what I'm gonna do, I'm gonna press F10 to execute this particular statement. F10. So see, the value of the variable A has changed to 0. So now if I press again F10, so now if I look at the console, there is nothing on the console. So now I'm gonna press F10 again to execute this particular statement. F10. Let's look at the console. Look at that. We got hello world 0 in the console. Now I am going to execute this particular statement. Scanf in this case. I'm going to press F10 again. So now it is waiting input from the user. So you can see that the yellow arrow mark is gone, which means that the application is running. It's not broken into the debugger. So I'm gonna press another digit, say 65. I'm gonna press enter. Look at that, we got the control back to the debugger, which is this yellow arrow is showing, and there is a blinking up the bottom. Visual Studio says that it got the focus. So I'm going to do. I'm gonna look at the value of A. So value of A got 65. So if I hover the mouse, also I can see that value of A became 65 from 0. I'm gonna do a printf. Obviously we know the output of printf, right? So it is 65. So I'm gonna stop debugging and I'm gonna give you one more input just to make the output look a little bit better. /n, which means that the output should go into a new line. So F10, F10, F10. So now it is 63. Enter. F10. So we got the 63 in a new line. So /n will print everything in a new line. So /n is nothing but new line, and that's it. Some of the things in this particular demo you may not understand completely, but we're gonna see things in detail. So we wrote a C program with the help of Visual Studio. So that's what the Visual Studio editor was, the place where we type the program. Then we compile that program with the help of actual compiler, which is integrated with Visual Studio. It is not Visual Studio, but it is the compiler. The cl.exe is a compiler which is integrated with Visual Studio. The compiler generated CPU instruction for the program we just wrote. So compiler created the equivalent binary information of the text file we have given, which is our program. The Windows operating system loaded that program and executed it. That is what happened when we press the play button, actually. So we are not discussing linking and all those complications at the moment, but this is a summary of the things which just happened. So we type the program in Visual Studio and given to the compiler. The compiler create the equivalent CPU instructions. So the Visual Studio started the program, which is the output of the compiler. Visual Studio started the program, so who is going to execute it? So it is OS. OS is going to load that program and execute the CPU instructions which the compiler generated. So it is who is executing the instructions actually? It is a CPU at the end of the day executing. No one else can execute something. So CPU, the chip inside the motherboard, executed the instruction, and we saw the output of that. So a lot of things coming into play. Visual Studio, which is the editor compiler who creates the assembly instruction equivalent to the program. Then Visual Studio started it, and that's why we are pressing the play button. OS loaded the application, and CPU executed the application. So let's discuss a little bit about the program. So we have seen the main function in the program. So the main function is where the execution begins from a C programmer standpoint. So it's just like any other function. It starts with a curly braces and end with a curly braces, which we can see here. So it starts with the curly braces and end with the curly braces. So in between we can write our code. I think we have seen that in the demo. Again, we have used the printf function we have used. So that is a library function which we have not implemented, but we were using it. And hello world, which we have seen, and the other parameters we pass like a, etc., are called argument to the function printf. So we'll see this in detail later. So why we need stdio.h or conio.h, which we have used? Because compiler don't know anything about printf. So we have to introduce some mechanism to tell compiler that printf is a function and we can call. That is where stdio.h comes. So stdio.h contains the declaration of printf, which means that stdio.h will tell the compiler, hey compiler, printf is a function which takes this arguments and return this value. So this is the reason why compiler is not complaining about printf. Libraries and functions. So why we use libraries? So everything in our daily life as well, we cannot do everything by ourselves. In this particular example, buying a car, which we have given. So buying a car, we don't make a car because car manufacturing is very complicated. You need to make the engine, these wheels, everything, body, painting, it's all complicated. Only experts can do that. That's why we don't make a car, but we buy a car. Just like that, some of the things, for example, printf, we cannot implement, we cannot make printf. We just call printf from stdio.h, like buying printf from stdio.h. In this case, we are not paying any money though. But we don't buy stuffs always, right? For example, the food. Sometimes food we make in the home. Sometimes drink we make. Like that, some custom tasks we do ourselves. Certain functions we implement ourselves. So that part we will see later. So in this case, we bought printf from stdio.h. So that is the concept. We delegated that particular task. to someone else, some other library. So what is a library? So library is nothing but header file in the context of C programming, of course, which contains functions like printf. And if you include that library, we can call the functions inside the library in our program. So we're gonna see important libraries. We will see how we can search for all these things at the end of this presentation. So what exactly is our program? It's just a text file at the end of the day with .cpp extension. Can be opened in Notepad as well. So we're gonna see that as well. So demo again. So we're gonna see what exactly we have created, what are the different files generated, etc., etc. So coming back to Visual Studio, so this is the program we have created. So if I right click on this program, in the extreme bottom, this is a feature in Visual Studio 2010 if I'm not wrong. Open folder in Windows Explorer. Click on that, or you can browse to that folder where you have created the project. So this is where I have created the project in this case. So I got a solution file, which is the SLN, and inside the solution I have multiple projects. In this case I have only one project, but I can have multiple projects. So this is the project files, VCX PROJ proj. So different Visual Studio has different extensions. So this is a project file. This is all generated by default by the Visual Studio environment. We don't have to worry anything about this thing. So this is our program which we have written. So let's open this program in a Notepad. So this is the exact same thing which we have written, which we are seeing here. It's the same program, only we are seeing without coloring and without that extra functionalities. So this is just a text file. Our program is just a text file, and it has no relation with Visual Studio other than the project and things like that. Now where is the output has created? So output has created here. So the output is test hello world.exe. So this is an exe file which we have created. So this is our output of the program. So this particular file contains the assembly instruction equivalent to this particular file. So this is a binary file. This exe file is a binary file, and it is called executable. So let's execute it without the help of Visual Studio. What I'm gonna do is I'm gonna start a command prompt and drag and drop the exe to it. So I just started a command prompt. So let me show it again. If I go to run, I'm pressing Window R, CMD. If I drag and drop test hello world.exe and press enter, I'll get the same output, 86, enter. So I got this particular same output. So this is a program which I have just created. So we have seen a couple of sets of file. One is the actual program and the output, which is here. So there are so many files which Visual Studio has created. For example, if you go into here, so there are two debug folders. So one is inside here and one is inside this. So there are two debug folders, don't get confused. So one is here and one is here. So this innermost debug folder is for temporary files. There are a lot of temporary files here. Some of them we will see later. So this temporary file, this obj file, is the output of the compiler. So coming back, so we have seen a lot of things with scanf and printf. So how we know more about these functions? That is where the search comes. So if you search with this name of these functions in any search engine, you will get more information about this. Let's see that. So this is my browser, and I'm gonna type printf. So let's see the output. So this is what the search engine gives here. So if I go into this, so I can see a whole lot of information about printf. So it's a huge function with huge number of functionalities. So some of the options we have used, it's here %d, which will print integers, %a, %s, which prints the sign of characters. So these are the other things which we have not discussed, but we can use as well. Some of the things could be obvious, you may understand. Some of the things you may not understand at this point in time, but you'll understand later. So these are some of the samples of how printf can be used. So if you go into the bottom of the documentation, you can see scanf as well, and some of the related functions, fprintf, fwrite. So we'll go into scanf. I clicked on scanf. So scanf again has a lot of things. Some of the things we have seen. So this is how scanf we can use the this is called signature of the function or declaration of the function. This is how the function is declared. So this many arguments it takes. So again, there are samples. So complete documentation of this function is there in the internet. So this is how you further explore about the function and the capabilities of that functions. It is not expected at this point from you, but it's good to know that things are there. And I think we are done. Thank you very much.